For problem one is dealing with the company's air pollution problem in their production process. And there are several government reduction requirements on this three. There's three major pollutants. Uh, the OR, the operation research problem here is to minimize the total cost of applying the pollution abatement method while satisfying the reduction requirements listed by the government. And part one is to formulate the the problem, and I have it like this. These are the cost coefficients, and this is the government requirements. And since x are the fraction of maximum feasible use, so it's between 0 and 1. And uh, I can run part 1. So the optimal cost is here, and this is the abatement method you should use. And for problem B, it's identify the sensitive parameters from part A's analyze. Oh, also there's a sensitivity analyze that I type in the console, but I don't have time to type it here. So I just show my screenshots. So you just type in the function here and optimize it, and then show the sensitivity analyze for uh, objective function and the constraints. And for part B, so I try to ignore that the x less than 1, and I got the an infeasible solution that x4 is a fraction that's more than 1, so it's not usable. So, and then I analyze the 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 sensitivity analyzed here. So I got that the x2, x3, x5 has the finite sensitivity range, and meaning that they are sensitive, and um, they need an extra close estimation. And these are the sensitivity parameters with non-zero shadow price. And specifically, that's the constraints of uncertainty about x1, x4, and x6. For part C, that there's the inaccuracy of the cost coefficient listed in table 3. So it's separated into two questions, that this is the 10% off and this is 10% up. And I run the process here. This is going up. And they increased by like 3 millions compared to the original one, which is 32. And this is decreased by like 3 units. And then I get the sensitivity table from part A, and I found that other all parameters except x4 are will change any change in that will change the optimal solution. So they the check mark means that it will alter the optimal solution. And for part B, it is try to build the dual function. There's two ways. That one is to first change the primary into a minimal function, and the other one is keep it as the minimum and build the dual as maximum function. And I got, this is for part B. So the formulation is here. That you first multiply the original primal by -1, and this so as you can see between the difference between these two is that um, the 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 signs here are all changed, and the greater than equal to is changing to minus to less than or equal to. And for part E, also the solution here is the same. So the y constraints. So y is served as the shadow price for x1, and their optimal solution is the same. And for part E, it asks us how much is the unit change in one pollutants will cause the total cost change in which direction. So I said that it will be up by this unit, which is shown in the uh, this is shown on the sensitivity analyze, and this is also shown in the sensitivity analyze. But actually, it's the same here. It's the y1, y2, and the y3, and the allowable range is also getting from the sensitivity analyze of the function, which is here. But this is for the -1, so we need to change into the positive. And for part F, it asks us if the particulate policy increased by 1, the surface oxide needs to decrease by this unit to keep the total cost unchanged. And these are the other conditions. So, and question G is asked us if the requirements is up by a percentage increase. So what will be the total cost in the terms of theta? So this is how I got the answer. This the y value is getting from previous here, the sensitivity analyzer of H at the right hand side. And for part H, it's asked you to try to calculate for 10, 20, 30, 45, 50. And my code is here. Every time I change the theta into different values, and I can run here. This is the optimal cost for theta equal to 50, and this is the answer that I run for the others. So, and then it asks us to minus, because the policy is that if you meet the requirements, surpass the requirement by 10%, you get 3.5 million tax off. So it's just minus the tax off. And I find that when the theta equal to 40 got the total up to the minimum total cost on abatement and taxes. And part E is just to repeat E and F, but with the different theta equals 40. And since the sensitivity is changed right here, so every number changed a little bit here, and also for part F changes. That's it.